The speed of light in vacuum is an absolute cosmic speed limit. Nothing can travel faster than approximately 300 million meters per second per second. According to the laws of physics, the closer we get to the speed of light, the more energy we need to provide to move an object. Since you need an infinite amount of energy to reach the speed of light, it is paradoxically impossible to reach this speed. You may have heard that an object moving at the speed of light gains infinite mass. But this is not entirely true. The object does not actually gain physical mass, but behaves as if it has gained mass. For example, if a 65 kilogram human were to travel at 50% of the speed of light, he would behave as if he had a mass of 87 kilograms. Or, if you made this person travel at 90% of the speed of light, this time he would act as if he weighed 172 kilograms. So how can light exist if mass cannot move at the speed of light? Because light consists of photons, which are massless particles, and just because of this, these massless particles and photons do not require energy to move. Naturally, if no effort is required to move particles of light, why can't photons travel faster than the speed of light? Because time expands as speed increases. Inevitably, as we approach the speed of light, time slows down, and once we reach that speed, time stops. There is no time for a photon, everything happens all at once. Trying to make a photon faster than the speed of light is like stopping your car and still trying to drive away. Naturally, this cannot be done both in theory and in practice. Time dilation, which develops due to increasing speed, always affects us in daily life. But its effects are so small that we cannot feel it. According to the theory of relativity, moving clocks are slow. So if you throw your watch off a cliff, the time it shows will be slightly behind the clock that was not thrown from the cliff. However, very sensitive measuring devices are needed to detect this difference. In addition, this applies to all mechanical and biological watches. According to the theory of relativity, you age slower at such high speeds. Of course, to discern so many differences, you'd have to travel pretty fast. For example, for 6 months, someone on the International Space Station would have aged 0.005 seconds slower than someone on Earth. Some satellites sent into space for scientific research circle the Earth every 90 minutes. However, the speed of these satellites is only a fraction of the speed of light. If you had traveled in a moving spaceship at 98% the speed of light for just a few minutes, it would have been decades on Earth for your friends. Compared to Earth time, all this massive time would have felt like a very short time for you and the spaceship crew. If we could see what was going on, a person moving towards you at the speed of light would appear blue. Because light waves coming into your eyes from an object moving at the speed of light are compressed and naturally shortened in wavelength. Generally, this is called blue shift. Similarly, if the person traveling at the speed of light moves away from you, the waves of light get longer. Inevitably, this lengthens the wavelength, and naturally, the person moving away from you at the speed of light will appear red to your eye. This is called redshift.